Hello all. We are delighted to start another panel in this 5th IBCI International Conference on Competition and Innovation, where we will talk about ethical design on algorithms, of algorithms. And we are very glad, delighted, in fact, to have a discussion with a professional and also a professor outside of our standard world, the legal world. What makes me very excited to
quite far.
Panel, yeah. So I'm telling you the truth, Amaya. I'm very excited to learn with you and with whatever you're gonna present us, because myself and Vinícius, we are from the legal side, and sometimes it's a little boring to only hear legal these speeches and etc. Not only boring, but I'm sure this panel will enrich a lot our repertoires. Myself and Vinícius, because we are in our 3rd year of research to discuss whether we should create another or propose another language for programming, or propose some commandments for programmers, not for lawyers, thinking of the most effective way to prevent distortions in algorithms. So we love this subject, and 3 years studying that without earning a coin, it's only for love. So myself, I do not need to introduce. Vinícius, a brilliant professor of the University of Paraná, Federal University of Paraná. Professor of law and professor of economics. And Amaya, if I'm not wrong, a computer scientist, right?
Well, mathematician, but
mathematician.
Yeah.
From University
working with computer scientists, yeah.
So yeah, an inside mathematician in the computer scientist's role. So
exactly.
The floor is yours, Amaya. If Vinícius wants to say something, please do now. Otherwise, later, after Amaya presenting us the news. Thank you all.
I just want to say that I'm very glad to have Amaya for the same reason, to talk with someone that's not from law and that studies the same subject in a different perspective. And I have been this year in the Université Côte at Nice, and I saw the work that Deep Law for Tech and the 3IA centers do, and it's a wonderful work. They have this interdisciplinary approach about law, technology, and economics. And we have a professor in our board here, Professor Frederic Marquis, that is from the same university as Amaya now. And I'm very glad to have someone from the Côte d'Azur University here. So Amaya, the floor is yours.
Thank you. So let me share the screen. Can you see the slides?
Yes.
Yes, can you see the, yeah?
Yes,
great.
Please, perfectly.
Okay, great. So thanks a lot for the invitation. I'm also very happy to discuss with people for quite a far field that are as well interested in this ethical design of algorithms. So let's start. To start, I'm gonna introduce briefly myself. So I'm a mathematician. I have a PhD in mathematics from the University of Seville. Then I have been working as well as a research engineer in a private research center in the Mathematical and Algorithmic Science Lab from the Paris Research Center. And then I arrived to Nice in 2020 doing a postdoc in the IBCI laboratory. And since October last year, I'm an associate professor in the Troisième Côte d'Azur, that is one of the interdisciplinary institute of artificial intelligence of France. Sorry, there are 4 institutes, and we are mainly working on artificial intelligence. So, what is artificial intelligence and what is machine learning? So artificial intelligence is definitely one of the buzzwords of the century. And in a broad sense, artificial intelligence is intelligence demonstrated by machines as opposed to the natural intelligence displayed by humans or animals. But since this is a very broad concept, there are many other disciplines that can be considered to be part of artificial intelligence. Machine learning is the most widely used artificial intelligence technique and is the one I will focus on this talk because it's the one I'm doing research. And but I would like to mention as well natural language processing, which is a subfield of linguistic, computer science, and artificial intelligence concerned with the interactions between computers and human language. In particular, how to program computers to process and analyze large amounts of natural language data. Or, for example, we have as well knowledge representation, which is a subfield of artificial intelligence dedicated to representing information about the world in a form that a computer system can utilize to solve complex tasks such as, for example, diagnosing a medical condition or having a dialogue in natural language. And more specifically, here we have the exact definitions of artificial intelligence, which is the science and engineering of making intelligent machines, especially computer systems, by reproducing human intelligence through learning, reasoning, and self-correction. And machine learning, here I propose you 2 definitions, which can be defined as a computer program, an algorithm that improves its performance measure P at some class of tasks T with experience C, or more generally, the field of study that gives computers the ability to learn without being explicitly programmed. So here we have again the same figure. Now we already know what is machine learning, that is a subfield of artificial intelligence. But one important topic of artificial intelligence concerns ethics, addressing the concerns raised by the increased use of artificial intelligence algorithms to make decisions that have important consequences on people's lives. And one particular ethic concern is fairness. And since fairness requirements constrain how certain data is handled by machine learning algorithms, it turns out that fairness in machine learning belongs to ethics in artificial intelligence. So fairness is becoming one of the most popular topics in machine learning in the recent years. Here I prepare an histogram showing the explosion of research publications in this field since 2014, which shows that the research community has invested a large amount of effort in this field. So let's start with the definition. What is unfairness, which is easier to describe than fairness? What is discrimination? So we can define it as wrongfully impose a relative disadvantage on persons based on their membership in some social salient groups, that is, race or gender. So this is very simple, single sentence, but is important that Here we are talking, when we talk about fairness or discrimination, we are talking about people. So the sensitive features, some social salient groups relate to people. So it's gonna be race, gender, sexual orientation, or something that affects people. I would like to give you what is not discrimination. For example, if we have a company that produces cars and there is some, let's call it wrongly, discrimination against red cars because they have worse sales than black cars, this is not discrimination, because this we can call it bias, but we are not talking about fairness. Fairness needs to involve or affect people. Okay. Then I give you here first an example, which is a note about machine learning. This example is about discrimination in natural language processing. Here we have Google Translator, and I just translated to simple nouns from Spanish, my mother tongue, to English. So I translated, as you can see on the right, doctor and nurse. The thing is that in Spain, in Spanish, the articles are not neutral, they are gender. So what I have written on the left, la doctora, it means that the doctor is a female, and the nurse, el enfermero, it means that the literal translation is that the nurse is a male, okay? But what happens when we just click on the reverse translation, so when we translate the doctor and the nurse to Spanish, is that magically the doctor is a male and the nurse is a female, okay? So this is one example of discrimination, of unfairness in natural language processes, or in natural language processing, or more general in artificial intelligence. So now, what is fairness? So in general, is the ability to ensure that different social salient groups are treated similarly. And more specifically, a fair machine learning algorithm implies that its outcome should not have a disproportionately large adverse impact on a protected class of features. So here we have the simplest machine learning life cycle, where we have on the left our input, X, our non-protected features, S, our protected feature, that is going to be race or gender. Then machine learning, which means that our algorithms will be applied to this input, and our output will be this Y hat that is going to be a predicted label. In the simplest case, we're gonna deal with binary classification, so it's going to be yes or no, 1 or 0. Okay. As an example, I'm gonna, here we have an example from a credit scoring data set, where each individual is represented by a collection of non-sensitive features and continuous features, okay? And a class level indicating if the individual is a good or a bad customer. Okay, so our sensitive feature is going to be gender as status. We have applicant 1 male married, applicant 2 female single. We have just income or credit history, and we have some input, this level that we know that applicant 1 is a bad customer and that applicant 2 is a good customer. And our machine learning algorithm is going to give us as output the decision on the right. Okay, so it will decide to give, for example, a loan to applicant 1 and 2. And the thing is that, why do we want machine learning? So that when we have an applicant 3, where we don't know if it's a good or a bad customer, is unknown the why, we still can take a decision because we already learned from applicant 1 and 2. And for example, for this applicant 3, the decision will be negative. The bank will not give the loan to applicant 3. If we see more in detail, it has the same income as applicant 1, the same credit history as applicant 1, but different sensitive feature. It's a female single. So this is one example of discrimination, of unfairness in a machine learning algorithms. And why this happen? So sometimes this is not intentional, is because we have less data for minority groups that leads to higher error, or for example, like in this case, because historical data reflects human biases and stereotypes. So if in history women have been discriminated or Black people have been discriminated, then the data is going to reflect that. We cannot change this historical data. Another practical reason why we should care about fairness is because it will soon become illegal, which relates to your field. So from the government side, I talk from Europe, from the European Union, they published in April 2021 the Artificial Intelligence Act, where they do not mention explicitly the word fairness, but they mention trustworthy and responsible, saying that to achieve this, it requires the awareness from all parties involved. So they mentioned that fines for violation of the rules can be up to 6% of the global turnover for companies. So this one practical reason to care about fairness. And one more personal reasons, it's because the machine learning applications, they influence what information you see online by predicting what content is engaging to you, by capturing and analyzing data from faces in order to enforce laws, personalize advertisement, and diagnose and treat cancer. So in other words, it affects many parts of your life. So it's highly related to your own benefits. And how do we care about fairness? By designing ethical algorithms and algorithms that target fairness in the machine learning life cycle. They fall under 3 categories, under the pre-processing algorithms, in-processing algorithms, and post-processing algorithms. So the first one, they work on data. So we have our original data that is going to be biased, and we will design an algorithm that transforms this data to remove the bias. Then we have, so in such a way that in the rest of the machine learning life cycle, discrimination will be not removed, but decreased. We have as well in processing algorithms where independently of the biased data the algorithm receive, it will be specifically designed to give outcomes less biased, more fair than a normal algorithm, a baseline algorithms. And we have as well post-processing algorithms that they work directly on the outputs. Okay, so we have our input data, we have a machine learning algorithm, and once we receive the discrimination outcomes, we are gonna transform it. So these are 3 types, and we can design one for each of these 3 categories. And in the research literature, we can combine that there are many possibilities, but they fall under these 3 different categories. So, and now I have been talking about being more fair or less fair. So how do we measure this? So here we have again the example from the credit scoring dataset. So we have the sensitive feature, the non-sensitive feature, and the label. So now we are gonna introduce a little bit of mathematical notation. So we will denote as S, the sensitive feature, as the label we are gonna denote as with Y, and Y hat is gonna be our outcome. And here we have one definition for fairness, that is equal opportunity. And we say that a binary predictor, Y hat, satisfies equal opportunity with respect to the sensitive feature S and the label Y if the probability, these two probabilities are equal. So what does this mean? This means that the protected and the unprotected groups should have equal true positive rate. So let's make it a little bit simpler. So when we think about the binary case, when we have Y equal to 1, we consider it as the advantage outcome and the advantage group, such as not defaulting a loan, the admission to a college, or receiving a promotion. So in this fairness definition of equal opportunity, we require non-discrimination only with the advantage outcome group. That is, that to require that people who pay back their loan, that is this Y hat, sorry, this Y equal to plus 1, have an equal opportunity of getting a loan in the first place. So I want that for, if we take S as these male or females, that if males and females, they are good customers, they have the same opportunity of getting a positive outcome, of getting the loan. This is equal opportunity. So now I'm gonna show you one motivating example. This is the last problem I have been working, which is a classification algorithm that can be used to perform large-scale classification and dimensional reduction with fairness guarantees. So here we have, again, the credit scoring example, where each individual is represented by a collection of categorical features. So it's getting a bit more complex. So this sensitive feature is not going to be only male married and female single. It's going to be male married, male single, and so on. I'm going to show you. So it's going to be a categorical feature. So categorical features are commonly represented by binary features, 1, 0, yes or no, equal to the number of categories. So this number can be up to several hundreds, like in a feature represented a nationality, or for example, animal species. So this example aims at first performing data reduction by clustering the categories of the sensitive feature into a given number of clusters, but doing it optimally in terms of fairness. So here, if we consider, now we have here the 6 different categories for the sensitive features. We have male, single, married, divorce, female, single, married, divorce, and we have one possible clustering, the one in orange, where if we consider women are the protected group in the first clustering, we cluster together all the women, all the female features, and in another cluster, all male features. This gives us an accuracy that is the percentage of success, is the percentage of correctly classified objects of 78%, and equal opportunity of 84%. But if we design an algorithm that it performs another clustering, like the one in green, in a more fair way, that is clustering alone the strongest category of the non-protected group, we could surprisingly obtain an increase in accuracy, but the most important, an increase in terms of fairness. And if we see a bit more in details this number, we see that the fairness metric is above 100. So what does it mean? We are talking in percentage and we have something above 100. So since 100 would define a classifier where the protected and non-protected groups, male, female, are being treated exactly in the same way, having it above 100 means this classifier is doing some positive discrimination. So therefore, it shows the huge impact an ethical algorithm could have in terms of fairness. So, but there are a few difficulties in the design of ethical algorithms. So the first one is that until now, I have only introduced one way of measuring fairness, but there are many different definitions, fairness definitions being used in the research community. So here I show you 7 different fairness criteria. They fall under 3 notions of fairness, which is independence, separation, and sufficiency. So it makes it difficult to, as you can imagine, to design an algorithm that satisfy one of these all or one or these fairness criteria. So the thing is that that's not the only problem, because we have as well what is called the impossibility theorem of fairness, which is represented by 2 different propositions that relate the fairness definition. So in the first one, we have that if the sensitive feature and the original label are not independent, then either demographic parity or predictive parity that are due to fairness criteria hold. And then we have a second propositions saying that if the sensitive feature is not independent of Y of the label and the outcome is not independent of the label, then either demographic parity or equalized odds holds. So then what we need to retain for this is that it turns out that in most cases, any 2 fairness criteria are mutually exclusive. So to summarize, the main challenges in the design of ethical algorithms in machine learning would be to properly trade off between the different notions of fairness. And then in order to technically apply this, there are a lot of parameters to fix, which cannot be left only to the designer of the algorithm. So there is a need to interdisciplinary collaboration on that. So for example, only to handle to solve the problem for the clustering that I show you, there are 4 parameters involved. To choose to tune these parameters, it cannot be only a choice of the researcher designing this. We need collaboration from lawyers, from philosophers, from economists. And then as well, the impossibility theorem of fairness makes it difficult to assess if a company is doing ethical artificial intelligence or not. So we need in some way a fairness criteria regulation, because since I just said, in most cases, 2 fairness definitions are exclusive, then it means that most probably any company could find one fairness definition of the list I gave you that they satisfy, but it doesn't mean that is the one they need to satisfy. So the fairness criteria to be used, it really depends on the type of problem we are solving. And from my point of view, this needs some type of law to be regulated. And finally, as a blue sky idea, the most difficult challenge would be, which will make things very easy, it would be to find a universal definition of fairness. But it's really a blue sky idea. I'm not sure this is doable, but I don't lose hope. So thanks for your attention. That's all.
All right. I don't know. I love it presentation. If you would share with us afterwards, I would appreciate a lot. And congratulations, Amaya. And of course, as I expected, you got my attention, and many questions arose in my mind. So let's see if I can ask some and share some ponderations. But prior to that, I want to know if Vinícius would say some words or would wait for to say after me.
You can ask, then I ask after you, no problem.
And of course, it's not a contest, so we can establish a straightforward dialogue, and I'm sure everybody's gonna love it. So, well, first of all, I have a question for how can I say, a dummy question from your world to my world. Okay, so I'm not sure if I understood 100% when you mentioned, if you suggested that okay, there is unfair results. It's a fact, and I like it very much that exercise you made using Google Translator. Perfect. So we have lots of unfair results in terms of algorithm or fuzzy logic systems operations outcomes. So many unfair, whatever it means, results. Okay. But I'm not sure if I understood if you suggested that programmers, owners, and people would need to have an algorithm to correct or mitigate distortions of a system operating in fuzzy logics, or if you suggested that we can introduce some artificial commands or lines in a programming to reach the same result, mitigating distortions. This is the first doubt I had.
So both things you said are true, because you are thinking, I think from your point of view, an algorithm, it's only an improper processing algorithm. But what I'm trying to say is that in machine learning, there are not only in processing algorithms. So we are working against unfairness, even if we work in the preprocessing phase, even if we touch the data and we do nothing on the rest, or if we take the final output and we change it. So both, all of these three cases are called algorithms.
Yeah, okay, gotcha. So, just to put everybody on the same page, because we are out of this, so this language, different language, and I'm sure
yes,
our attendees are as well. So, algorithm could be classified like a line of programmation, period, right? But we can also
Can I give you one example, maybe to make it easier to understand? So if we take the example I said from credit scoring, so we receive some data which is related to clients, Then we have an algorithm in the middle that gives an outcome saying, I give the loan to this person or not.
Okay.
And then we know this output discriminates. So then we have 3 different ways of designing an algorithm to solve the issue. So we can act in the middle. So we replace the algorithm we had, we change for a new one that creates better outcomes. That's fine. But there are other possibilities. So we know that our algorithm is not good because our data is biased, is historically biased. So then we can change our information about clients. It's allowed. You can think that we are lying because we are changing, but this is one proper way to achieve the same outcome. Then we don't change our algorithms in the middle, and we will obtain finally better outcomes. Or the third possibility is that we have our biased data, we have our algorithm, then we have our result, alone yes or no. We know because we can measure these results discriminate, and then we change. And then we have another algorithm that says, okay, to this person, to these women, we said no. We need to say yes based on an algorithm, of course, not only a personal opinion.
Okay, very clear. So translating to like a common language, we have a disease, so we can combine medicines, right? We can rewrite.
Yeah.
We can rewrite the DNA of like a agent that we insert into the body, or we can do it in addition to like changing the raw material of the medicine and adding another one. So 3 medicines to cure the disease or to mitigate the result. Is that correct? That's right.
Yes, which only complicates things because we are saying that we have 3 different type of algorithms. We have at least 7 different fairness definition. I also say that you can combine algorithms. It's not that you can only have to use one. So you have multiple possibilities of solving the problem.
Yeah, but I would say that it's not like a bad result of. It's not a bad fact because as long as we can combine whatever we want and can to reach out to the desired result, good, right? So
yes,
but of course, and now I will put a question and a ponderation, and Vinícius can jump in as soon as he wants. Okay, so but now is the difficult question: what is fairness? You brought to the discussion. Right. Of course, I mean, treating equal individuals differently might be an unfair. But all right. So as long as we have the fairness definition, what is very like almost a metaphysical question sometimes, but as long as we have the fairness definition, we will be able to identify the unfair results of an operation, right? And you just taught me that we can, I mean, just create obligations to the programmers, owners, and whoever operates the algorithm or the artificial intelligence realm, and oblige them to reach out the results to mitigate unfairness, period, right? But this is not an easy task, right? How in your experience, you are seeing the pursuit of this task? You know, how people are working to pursue this task nowadays in the platforms. I mean, are they educating the programmers, or are they I mean, investing in algorithms to mitigate distortions? What have you seen so far?
I'm teaching data scientist.
Yeah.
So I'm trying to put a bit of to help a bit on the topic. So I'm teaching in a master course that is called Ethical Aspects of Data, where I try to make them responsible of this, because I'm telling them, so in 2 years you will be working for a company and you will be dealing with data sets that contain that are biased or that affect people's lives. So you are responsible to inform your superior and to find ways of mitigate this discrimination. But I mean, this is just what I'm trying to do. Practically, what I can tell you is that since last year that it appeared, the Artificial Intelligence Act, we see a lot of job advertisement with in the job description some paragraphs from the Artificial Intelligence Act. So they are hiring people to work directly on this, because so they mentioned already 6% fines for violation of the laws that we already don't know, but these things you cannot solve it in not in one day, but maybe not even in 1 year. So they are hiring people to form them on this, and not only on fairness but on transparency, which is as well very important to avoid this type of black box algorithms that if in addition of giving you a discriminated outcome, they are black box, so you don't know what they are doing with the data they receive, then they won't pass the law. Whatever the law is, they will violate it.
Thank you.
So the practical answer is that they are hiring people to work on this.
To do
and
something.
They are looking for and companies they are currently looking for collaboration in university to work on the topic.
All right. I'm sure Vinícius has a lot to add because he was researching on transparency, right, Vinícius, in Côte.
Yes, I was researching on transparency, and thanks, Eduardo. Thank you very much. It was like fantastic, this presentation, and seeing your effort to try to pass the message in a more clear way, and it's very good for us. Like when I think how design of an algorithm will write fairness or unfairness, like now I can see in more concrete way how is this possible. So it's fantastic for us. And I would like to, I don't know, maybe some of the questions are not so are misunderstanding from you, but one of the things you said, one of the slides, that because if the sensitive variable like male, female, it's independent or dependent of the outcome.
It is dependent. So the thing that the result of discrimination is because the algorithm outcome made kids dependent.
But the accuracy, because at least in a more like simple point of view, like if I, for instance, if I could take out the male or female variable, like the algorithm does not use that variable. He doesn't take this male or female or married, divorced, or something. And for me, like this could be like a simple way. If you think like outside of mathematicians, this could be like a simple way to not have bias, because if this is not gonna be used, probably the result will not take this into account. So there's gonna be no bias. But your way is clever. You use this and have accuracy and maybe avoid the bias. And I think relate to that, like it's not you have you are designing your algorithm that can see if the data is biased or not biased. The solution could be to make companies produce more data, because it's not the algorithm that's doing bias, it's the data. For like one kind of point of view, like the data is biased, so of course if you put a task, is gonna the source is biased, the result will be biased. But it's maybe in the medium terms, it's possible to have like a more balanced data for these things?
Yes. So one thing. So what you mentioned about removing the sensitive feature is the first idea that comes to our mind, and in fact, some type of algorithms that that enforce to use either disparate, what we call disparate impact or disparate treatment, they oblige to not use the sensitive feature. Okay, they for example, they're in the US, there are already one law that is called the P percentage law that deals with disparate treatment, that obliged to satisfy 1% of an 80% rate between females and males without using the sensitive information. But in reality, it has been proved that removing the sensitive feature and doing what we call blind classification, a blind algorithm, that not solve the problem, because the other features are correlated with the sensitive feature. So even if you remove them, with the rest of the feature, you can infer the value of the sensitive feature. So it's not enough. So this answer is clear, is not enough. Then the second thing that you mentioned, that one way would be to generate more data. This is a valid solution, but there are many different type of bias. It can be historical bias, which represents that that just represent the human biases from the past. And we have as well another type of bias that is called representation bias, where some minorities are underrepresented. So in these two cases, generating more data could solve the problem. So there is one well-known example. I don't know if you know, there's a woman called Jo Buomlukwami that she pointed out the discrimination of commercial face recognition system against Black females. So she has a YouTube video, very interesting, showing how this commercial face recognition system, they fail to recognize most of Black females. She shows examples with Michelle Obama, with Serena Williams, with many other females, and they are either not recognized by the facial recognition system or recognized as male. And this is because of representation bias, because in the data set where this algorithm was trained, there was not enough data for Black females. So then the algorithm doesn't know how to recognize. So if you train your algorithm with more Black female faces, then your algorithm will do it better. But there are another different type of bias that cannot be solved only on that way.
Yeah, can I? So following this reasoning, maybe we could understand that there are natural bias on natural world, right? So every culture has its bias. So it would be like impossible to mitigate every bias from every culture. So, and every culture has like bias and minorities, so unbelievably complex to solve, including using AIs. But how do you, Amaya, how do you see, have you heard about protocols? I mean, protocols of programmation are like some main principles that maybe we should think of having as like a broader guide for us, for whoever wants to work with AI, be biased by them. I mean, always looking for like more transparency or more like interoperability, or like how can I say, friendly APIs and so forth and so on. How do you see this? Have you heard about them? And how do you see this, like these tools, like as mitigating factors or some kind of medicines to this?
So for this, what I like to say is that I don't want to be the responsible for that. So I give the tool, and then the company, the lawyers, or whoever, I give you the parameter to tune, and you take your decision. Because in these machine learning examples I told you, since we are dealing with classification, which is yes or no, achieving 100% fairness is possible. It's possible. It's
Okay.
achievable. The only thing is that it's not free. That's a problem. If you achieve 100% fairness for free, then why are not doing it? We are not doing it because it implies losing money. Because if a bank wants to have 100% fairness in their decisions of giving a loan, they will make more errors. So they decrease accuracy. That's a problem. So I give you the tool, I give you a parameter, and then you design a law to oblige the company to make it better. How much? 20% better? 30% better? I don't know, but I don't have the knowledge to make this decision. I mean, this is more in the philosophy side. What is fair or not? Wow, we're discussing about ethics.
Yeah, but we have a point, because we had this discussion, exactly the discussion, I mean, 1 year or so ago, right, Vinícius? When we were talking about like this research, whether we could like have a protocol, like a mandatory protocol for the companies, for the owners and the programmers, to for them to unnaturally limitate the efficiency of the operation of the AI system, but targeting goods, targeting welfare, right? Only by law they would, I mean, only by a law and their heavy penalty, and their threat for heavy penalty, they would go through this way. Or if they believe doing so, they will lose in the short term, but the society will have a lot of gains in the long term, right? Okay, but when we talk about fairness, I agree with you. I mean, I believe it's very difficult to define what is fairness. I mean, maybe we have 100 types of fairness, maybe 1,000, women infinite, right? But it's very easy to define what is a crime, right? So what is a crime? I mean, I know what is crime. You don't need to be a lawyer or a law student. A law student to know that killing somebody in some circumstances is a crime. So robbing or stealing is a crime. So we know what is crime. And we know, I mean, it's very 0 or 1 to know if we face a crime or not, right? So you gave me you gave me what I was looking for. We can set up a group of rules obliging people to avoid crimes in the operation of AI, right? Am I right?
Yeah.
You make them lose money, okay, but it's not about the money. We're talking about like higher targets living in a society, right?
Yeah,
I appreciate a lot. Vinícius, please.
Yeah, like in this jumping in this reasoning, you said that it must be from law, and I agree, because if you're gonna say you have to lose some money in the accuracy and have fairness, and there is levels, like you, for instance, do you need to have a positive, do you need to go beyond 100%, as in our example? Is the company's role to make this positive discrimination or positive effort, or it's not? And for instance, in credit, you can have some problems if people don't pay the money back. But one of the things that I would like to listen to is like how to do this in law, because in the law could say you have to have to correct some level of fairness, for instance. Like let's just pick a number. Like for instance, there is a law that say you have to compensate 20% of bias or unfairness. And how it's I do think it's gonna I think it's gonna be hard, but I would like to listen to you. It's gonna be hard to enforce this law because I will have to have some kind of a government agency having like this protocol, this algorithm seeing like, or do you think the company must sometimes prove that they try to compensate because it's a cost for the company to do, but it's a cost to enforce that also. How do you think of this? I know it's not your field, but
Yeah, I think in this case, in order to show or to prove fairness, the solution must be related with transparency. And then it comes as well the things of privacy, because if there's a company, we are discussing about machine learning, so we are dealing with data, and they need to prove they are doing it in a fair way, then they will need to show their input data, which I don't know how does it go with the privacy law, in order to prove their outcome is fair. So I don't know. And there is a second problem that I mentioned, that is it will be always possible to choose a fairness definition that they will satisfy. Yeah. Because there are many different definitions that they are incompatible. So it's not only to prove fairness, it's that to prove fairness with the right definition or the right criteria of fairness. Honestly, the practical way of implementing it, I don't see it very clear. But
yeah, if I may help you, Amaya, I would do the same as follow a similar path that the EU decided to go through in the DMA-DSA Act, that is shifting the burden. We can we should look upon the results. As long as we identify what is fairness, unfair, or what is a crime, to make it easier, we look upon the result and see, okay, there is this is Google, and I found 10 unfair results, and we have the unfair right written in the law. Or I found X and Y crimes here, and I don't know how they happen, but I know they happen inside the realm of Google or the platform or whatever, and so Google is liable. Oh, this is really unfair to Google because it's gonna imply a lot of costs to them to monitor, etc., etc. Yeah, it's true. But this is if I'm not wrong, this is the path the European Commission decided to go through in DMA, DSA, and in the AI Act, if I'm not wrong, is too, right? So
it's not really that they are losing money. It's like that they were gaining money in a wrong way. So it's not really losing.
Yeah, I just played the devil advocate. On their side, they would always claim for this is really unfair. You're about to kill the innovation, etc., and the all North American speech. It's you're going to handicap the innovator, etc. But in the end of the day, we have lots of distortions. In terms of jeopardizing people, hurting children. All lots of types of abuses. And what do we do? It's difficult to apply like the traditional tools to monitor and to catch them up. Okay, it's difficult, it's impossible. So we found a new tool, we shift the burden, and then not me, but others. We shift the burden, and as long as you have a clear a clear picture of the result, the outcome, you make them liable. So they would work hard, I mean, hiring people to help them to mitigate or to make it not happen, right? I don't know. Just a reasoning.
Yeah, and like this thing about you said in the end, like it's very interesting, like a universal concept of fairness, and that's another point I think that is interesting, because do you think like you, in your point of view, like different industries or different sectors of the economy will have different definitions of fairness? For instance, you gave this example of credit markets and borrowing, but maybe if you talk about clothes or food or something else, do you think you have to have a different definition of fairness in your?
Yes, because I mean, in some easy example. So, for example, equal opportunity, the criteria I told you about, it only requires fairness among the positive group. So, with the credit scorings, it means that if you are a good customer, you will not be discriminated. So, if you are a bad customer, they don't care about you. So then, if we only use equal opportunity, they might be discriminating bad customers, but we don't care about that. But then if you think of a different example, for example, in cancer diagnosis, so it might change. So so being positive will imply that you have been diagnosed a cancer. So you want to imply that the correct accuracy for the people that are finally they had a cancer is the same. And if you don't care about the negative ones, the one that they were not diagnosed, is more serious, because then the false negatives, so the people that you diagnose negative, but in fact they were positive, you are not taking them into account. Okay. So and we care because there might be a discrimination on that. So if this grown decision of not diagnosing somebody with a cancer is based on race or gender, then you are not using, if you use equal opportunity, you are not using the right criteria. So that's the key point.
Yeah, and oh, very interesting, because if you think about like a better or a standard for an agency, it must be like a different kind of sectors of the economy. You're gonna have a different kind of way of seeing this. And one last comment by me about transparency. Like I think sometimes the burden of the transparency is treated like a very optimistic way, like it's going to solve more problems than it can solve actually, because it's hard to, I think if you can, like, you must have transparency about the data used for training your algorithm. But like if you have in a country that has not the infrastructure to have an algorithm that can understand how this bias works, this transparency is gonna just be a cost for the company. It's gonna have like a register of that, and because you have to have some kind of institutional capability of the people that are analyzing the algorithm to see if to see the things that you showed us. And the thing that's how do you think about that? What's the extent of transparency that it's cost effective? You have transparency and you really have a good output.
Yeah. I mean, I agree with you, but yeah, when the excuse for not being transparent is only money, or that they will discover that the data is biased, then for me is not enough. It's not enough. I would like. I forgot to say something before. I think you said something about positive discrimination, and I would like to say that then the thing of doing positive discrimination, it might not have all the time, let's say, a financial impact, because, for example, if we think of a problem of the acceptance rate to university, so if you try to impose positive discrimination from people that didn't have the chance to go to a private school, or they were living in very poor areas, so here there's just no loss of money. So you are trying to stabilize the social bias, the bias from the society that you couldn't change with the salaries of their parents. But then they arrive to university, and then you you do the change there. So it's not only about money. So I think there are many things that can be done to improve society.
Hello, Eduardo. There is a question in the chat. One of our artists is asking if you think it's still good for society to use algorithms like this that have this bias.
Sorry, if what?
If it's good, if it has a good output using these algorithms, if you don't have these controls, like it's still valid to keep using algorithms.
If I didn't understand.
Maybe
that one solution to improve would be to stop using which type of algorithms? Which type?
I understand as well.
The unfair algorithms. Imagine that this bias keep happening.
Yeah, but the unfairness does not come from the algorithm itself.
It comes from the data, from society.
Data. Yeah.
If you stop, I mean, if your data is not biased, and then the problem is only the algorithm, then you change the algorithm and then you solve the solution. Yeah, I mean, you cannot stop. The algorithm is there for something. You replace for something better.
Yeah. Actually, he qualified a question. I mean, the credit score algorithms. I mean, the credit score, right?
Yeah. I mean, you need to stop, but not. I mean, you need to change the algorithm. You cannot stop. You need an algorithm to take the decision. So the algorithm will not stop giving loans. They need to continue giving loans. And if you want to try, it's very funny. I don't know. At least here in France now, before you go to the bank to have an interview with whoever there, they have their own application, so that you feel your saving, your income, your saving, your gender for sure, and you can play with that to see the final outcome, and you will discover discrimination in 2-3 times you play with that, you will find out. They lose money if they don't do it. So until it's illegal, they won't stop.
Of course, and maybe this is the very same ideal solution, not achievable. I mean, don't use the internet anymore. So, but maybe we should keep going into and looking maybe to building up algorithms to mitigate distortions, or maybe create incentives, legal incentives to like kind of a filter data and qualify, make them more, more qualitative in terms of reducing their level of bias or whatever. As using your idea to combining medicine. So, but in terms of incentives, this is something that it's already occurring when we see this new modern acts from the EU. I mean, like DMA, DSA, the AI, and there's the Data Governance Act, if I'm not wrong, right? There's another one, Data Governance Act, right? Is that right? I'm not following everything in Europe, but if I'm not wrong. So, in terms of incentives, creating, and as long as the law shift the burden in terms this new giants, these new rich giants, as long as they have they fear some huge fines, or they are threatened to be, I mean, dismembered and the like, they will create markets, I mean, for people to filter data, to work on innovative solutions to reduce biases and reduce discrimination. This is the way I see in the future. I mean, the end of the tunnel, the light. So, but going back and not using them, I don't see as feasible at all. But I appreciate a lot this discussion. I hope you too, Vinícius, my friend, and Amaya. Amaya, congratulations for your work. Amazing.
Thank you.
And I would like to thank Frederick as well. Frederick Marti, who made this happen. If Frederick was not with us, I don't know if the years ago, I don't know if we would be able to be here. I mean, today, right, Vinícius?
Yes, if it's not Frederick, we will not have go to Nice and know about the 3IA Center and have and know your fantastic work on this. And yes.
Yeah, thanks to Frederick. So I hope you see this video afterward, Frederick, my friend. And why not next year we can make it in presence?
Yes.
So these are my final words. Thank you very much to all. Vinícius and Amaya, please.
Thanks for the invitation and for the discussion. It was very constructive to see your point of view. See you next time. So if you come again to the University, Université Côte d'Azur, I will be happy to organize a seminar or something.
Thank you,
Sure.
Amaya. Thank you, Eduardo.
I think we have time for one or two questions. Vinícius, you have some?
So I see in the chat that the person that asked about the credit scoring say, go back to good old-fashioned human work. This thing I don't recommend at all, because I think we are mainly the problem, humans, that we are biased. So I won't trust people to take the decisions. I prefer to teach machines to be more fair, rather than convincing people to be fair.
Yeah, in this sense, I recall a book, I mean, Noise. I read this book on behavioral economics, Noise. I think it's Kahneman, if I'm not wrong, and 3 authors.
Sustain and Kahneman and one more author,
yeah,
I think.
Very interesting.
So
book.
for me, I like to. So last year when I started teaching, I found students in the course that they couldn't understand what was unfairness. So they thought that if to be fair implies that a company loses money, then it's not fair for the company. So then this year I started, so I take as granted human rights. So then I start from this basis. So that's why I prefer, if you are racist, I don't care, it's your problem, you need to solve it by yourself, but I'm gonna show you how to make algorithms that are not racist. So yeah, I trust a little bit more algorithms.
Yeah, because I think like if I hire someone to design for me an algorithm, and this guy says, and the algorithm loses accuracy, this must have a reason, because if I just think about the guy who is hiring someone to design the algorithm, and he says, oh, I could have like 100% of accuracy or 99%, but gonna have 85 or I don't know, 90% of accuracy for the good of society. I understand that that someone has to say, oh, you have to do that because otherwise other companies, other companies that make the competition, if this guy is gonna have more money and he's gonna have a problem in this thing. But and it's hard to say that I understand that you have to teach the people that design the algorithm how to do it, but if you like say it could be like a personal responsibility, it's too much. The guy is in a company, he has to follow orders, or someone hired him to design the algorithm. So this idea that the company or someone who the people or the company who hired the design of the algorithm should be the ones who accept or have the state by the law making him accept that he has to lose some accuracy to have have a little fairness or more fairness. And I think
that's why we need you lawyers. That so I teach how to do it, and then you oblige people to do it.
Great. Again, we should, I mean, I think it's sooner rather than later we will see, I mean, a very different world in terms of rules and settle and the matrix of liability. I'm sure about it. Everybody who has a tiny role in the construction of an operation in an algorithm will be possibly liable for something. And so very careful when drawing or writing down programations and so forth and so on. But let's in the future. Okay, guys, nice. So we finished. I mean, this is my fault. We finished 10 minutes earlier. I thought our panel would finish like 15:15 and 15:30.
No, but I think it's good we made all the points. I think with your mind, but no.
All right.
Ricardo, okay. You wanna like Ricardo is more optimist about human beings. He says that he prefers to educate and enlightenment on human beings. It's a different position.
Yeah. I mean, the thing is that I'm teaching data scientists. I'm not teaching human rights. So what I say is that I take for granted human rights. That as me as a mathematician, I'm not able to teach human rights. So that I want to do is that they take for granted human rights and they design algorithms that satisfy this condition, and even they make it better, because of course an algorithm that discriminates females against male, for me it doesn't satisfy human rights.
Nice answer. Okay, guys. I think we can finish.
Yes.
Vinícius, Amaya, and everybody who kept attention on our panel. Thank you very much. It was
You're welcome. Thank you.
I hope to see you in person, Amaya, next year. Why not here or in France? We can talk about it. Vinícius, thank you again.
Great, for sure.
Thank you, Eduardo.
Please keep following IBCI in the next panels, and we will release all panels on the YouTube channel in the next week. So pay attention to this. Bye-bye.
Bye.
Bye.
Bye. Bye.
Have a nice day.